So here's a simple demonstration of cryptographic algorithms, specifically block cipher modes. So CBC, otherwise known as cipher blockchaining, adds randomization into the block cipher process. So this starts off with the initialization vector, which adds randomization, and is XORed with a plaintext block, which is then added to the block cipher encryption with our symmetric key over here, thus creating the ciphertext. Now for the next plaintext block, instead of using the initialization vector to add randomization, we're going to use the ciphertext to be XORed with the plaintext, which is then added again into the block cipher encryption with the symmetric key, thus producing our next ciphertext. Now, the ciphertext will be added again into the third plaintext, and the process just continues. Now for CTR, or counter mode. So this acts like a stream cipher and has a fixed counter size which replaces the fixed information. So you can just add any amount of information to be encrypted. So instead of using a 128-bit block, you can use, you can stream and encrypt 8 bits at a time. So for example, we start off with counter, which starts off with 0 or any preferred number really. And this is encrypted with the block cipher encryption with the symmetric key. And the plaintext is XORed with this result, thus producing the ciphertext. Now for the next plaintext block, we'll use the same counter but add 1 to it. And this is again encrypted with the symmetric key in counter mode. And the plaintext is XORed with this result, again creating the ciphertext. So as long as you incrementally add numbers to the counter, you'll just continue adding randomization into the ciphertext. And that is how the CTR and CBC block cipher modes work.